So this is your EA4 for Unit 3. This is your review. So Steve is spending part of his summer vacation at Camp Euclid with some of his friends. On the first day of camp, they must pass an open water swimming test to be allowed to use the canoes, kayaks, and personal watercraft. Steve and his friends must be able to swim across the river that they will be boating on. The river is 24 meters wide, so I'm sure that is very important. On the day of the test, Steve begins on one bank and tries to swim directly across the river to the point on the opposite bank where his counselor is waiting. Because the river has a slight current, Steve ends up 28 meters downstream from his counselor. So this is a very bad picture of his counselor here. And this is Steve swimming across the water. So it looks like he ends up 28 meters. Well, first, here's how wide the river is. We said it's 24, so let's mark that first. 24 meters. And then here's his counselor, and then he's 24, we'll say his counselor is right here, 28 meters away. So somewhere right here, 28 meters is where Steve lands. So when he was swimming, totally not a straight line here, he went at a slant because the current took him as he was swimming. The ocean is like that too if you've ever gone swimming in the ocean. There's a current. So I need to know how far away, basically what the hypotenuse is, because we're saying right here is a right angle. So we're labeling the diagram for the problem situation, and I think that we did that. Okay, now it says, how far does Steve actually swim? So he swam more than 24 meters because of the current. We have to go ahead and find that. So let's go ahead and say 24 squared plus 28 squared. As you can see, this is my A and my B. And remember, it doesn't matter which is which. But let me write the Pythagorean theorem. A squared plus B squared equals C squared. This would be my C for my hypotenuse. Okay, equals C squared. If you use your calculator, 24 squared is 576, and 28 squared is 784. Okay, and when I put those in my calculator, add those up, I get 1360. And remember, the last step is going to be to take the square root of both sides, so I have C by itself, and that equals 36.9 meters. All of this has been in meters. So now it says justify your answer. Sorry, the word answer is way over here. When I printed this off, it had a little issue there, but I need to justify my answer. So Steve swam 36.9 meters, and we found this answer by using the Pythagorean theorem, since the problem made a right triangle. Okay, so there's my justification. All right, so now it says Steve's friend Adam started at the same spot, but he swam 40 meters. So out here is 40 meters. It's going to be longer than this 36.9 meters, right? So our triangle has a little bit different hypotenuse this time. And we know the river didn't get wider, but now it's saying how far downstream was Adam from their counselor when he arrived at the opposite bank. So he arrived over here. So here's Adam swimming. He doesn't know how far he is from Adam and Sam's counselor. So if I use the Pythagorean theorem again, because I still have a right triangle, 24 squared plus B squared is going to equal this 40 squared. So that is 576 plus B squared. 40 squared is 1600. And now I have to subtract this 576 from both sides in order to solve for B. So b squared is equal to 1,024. Okay, and I'm going to take the square root of both sides. So b equals 32 meters. So justify my answer again. Adam was 32 meters from their counselor because the problem formed a right triangle and the distance was a leg. Right? Up here we could have even said that for number 2 we could have said that the distance was the hypotenuse of the right triangle. We could have added that to be very complete. Alright, so in a lake fed by a river, a triangular area marked with buoys is roped off for swimming during free time at camp. The distances between each pair of the buoys are 50 meters, 60 meters, and 70 meters. Draw and label a diagram for the problem situation. Okay, so I'm just going to draw a triangle. I have no idea if it's a right triangle or not, and probably would look a lot nicer if I used a straight edge, but I'm not going to because I'm a little lazy today. Sorry. So 50 meters a little bit shorter than the 60 meters, and 70 is the longest. So there's my diagram for my buoys, nothing fancy. And now it says, is the swimming area a right triangle? Justify your response. Okay, so first step, I'm going to use the converse of the Pythagorean theorem, which means I'm going to pretend that the longest side is C. So we're not sure if this is going to be equal or not, but 70 squared is going to be my C because it is the biggest side. And the other two, the order doesn't matter. So 50 squared is 2,500, and 60 squared is 3,600, and 70 squared is 4,900. And so I have a little question marks there because I'm not sure if they're equal. And it turns out that they are not. This is 6,100 is not equal to 4,900. So no, because $50 squared plus 60 squared does not equal 70 squared. Okay? And you can say, you know, right triangles means I can use the Pythagorean theorem if it were true. Converse of the Pythagorean theorem is what I would write. Converse of Pythagorean theorem. Okay, so I justified my response. Alright, so number 6 on the back. Okay, so here we have missing links on each of the triangles, and we need to be able to show all our work and round to the nearest hundredth if necessary. Alright, so let's see here. I hope your numbers are the same as mine. For some reason, I feel like mine are different, but we'll find out here. Okay, so if A, always start with the Pythagorean theorem because they are right triangles. So I've got, this says it's B, so I'm going to leave it B. That means the other leg is 24 squared and the hypotenuse is 17 squared. So given the hypotenuse and one leg, this means I need to subtract. So 24 squared in your calculator is 576. And 17 squared is 289. Yeah, this doesn't work. Oh dear, I have got the wrong numbers. Okay, so in class I'm going to have to fix that for you. I had 51 originally. So we will fix that in class before you guys have this review on your own. So this one's a little crazy. Sorry. It's my typo. When I rewrote it, I messed that up. Okay, so 51 squared, this should be better, it's 2601. Goodness. All right, and then subtract 576 from both sides. That will give me b squared equals 2025. Last step is to square root both sides, and that gives me 45. So round to the nearest hundredth isn't necessary in this case because I got a whole number. All right, so I think I still have wrong numbers on this one as well. I think this one was supposed to be 36. So I'm sorry if you've already worked these out with the wrong numbers. You just need to fix it. Go ahead and erase. If you need another piece of paper to attach that, this is my fault, okay? So I apologize. I know that C is correct, so we're good there. So B, it looks again like I have a hypotenuse and legs. So 36 is the one leg and A is my missing leg. 45 is my hypotenuse. So 36 squared is 1296 plus A squared equals 45 squared, 2025. And now if I subtract 1296 from both sides, I get A squared equals 729. And I square root both sides. That gives me 27. So nice even number. I don't have to round to the nearest hundredth again. Now this one I'm not going to subtract. I have two legs, which means when I put them in for A and B, I'm going to add. So this is 25 plus 25, which is 50. And then when I take the square of both sides, the square root of 50 is 7.0716. Here, let me just write some of this out. Dot, dot, dot. So round to the nearest tenth is this place. I look next door. It's bigger than 5. So 7.1 is my final answer. Okay, I apologize for my little typos there. All right, number 7 says, determine which of the following sets of triangle side lengths form right angles and justify each response. All right, so this is where we're going to use our converse of Pythagorean theorem. So I'm going to look and see which one's the biggest number. That's going to be my c squared. So this is 16 squared plus 30 squared equals 34 squared, question mark, right? And when I square, I get 256 plus 900 equals 1156. Let me just double check that math real quick. Make sure, yeah. Okay, now this is again a question mark. So when I add 256 and 900, I get 1156 equals 1156. So that is true. So it is a right triangle because 16 squared plus 30 squared equals 34 squared. Okay, because up here it was a question and now I know it's true. So down here, looking for the biggest side is 21, so that's going to be my c squared. Remember that always the largest side is your hypotenuse. So I get 100 plus 121 equals 441. Right? We're using our calculator for these squares. I just happened to work most of this out prior. So when I add these two together, I get 221 does not equal, okay, I forgot my question marks, does not equal 441. So it is not a right triangle because 10 squared plus 11 squared does not equal 21 squared. Okay. Last one is our crazy fraction one. And so I have to look. These are all in fifths. So which one's the biggest would be 10 fifths. So that's helpful that I have a least common denominator here in a minute. I have to add them. So I have 6 fifths squared plus 8 fifths squared equals 10 fifths squared, question mark, right? I'm testing to see. So this gives me 36 25ths plus 64 25ths maybe equals 100 25ths. Okay, so when I add 36 and 64 across the top, I get 100 25ths. and that does equal 125ths. So it is a right triangle because 6/5 squared plus 8/5 squared equals 10/5 squared. And yes, the parentheses are necessary when you have those squares on there. Otherwise, you're just squaring the numerator and it does not work. All right. I feel like it is a right triangle, I feel like Maury Povich or something. Okay, number 8. After the swimming test, Alex makes his way back to camp, and on a coordinate plane, Adam is at the point -5, 4. So I'm going to plot that first. -5, +4. And camp is at 3, -1. What is the shortest distance Adam will travel to get back to camp? Assume each unit of the coordinate planes represents 1 kilometer. So I need to know this distance right here. Again, not a straight edge, but... So what I'm going to do is I'm going to drop the right triangle. That's what I call it. So right here ends up being a right triangle with an unknown hypotenuse. So if I measure 1, 2, 3, 4, 5, I'm sorry, not measure, but find by counting. 5 squared is one leg. 1, 2, 3, 4, 5, 6, 7, 8 is the other. Okay? So I need to find the hypotenuse. 25 plus 64 is c squared. 89 is c squared. Square root both sides. I end up getting 9.43. Okay, and it doesn't say where to round. I have been saying to round to the 10th place all week long, so let's stick with that. C is 9.4 kilometers away. Okay, that is the shortest distance between 2 points. It's always a straight line. Okay, so if you go back and look at your rubric, this is your grading rubric that's on the front of your review, and you can go back through and see, did I correctly draw and label for each problem situation? That's what's going to be applied to number 1 and number 4. So I would lose points if I only did one and not the other, right? Correctly draws and labels one of them, or does one and doesn't even try to draw the other. This one's, I made a mistake on one, but I drew them both. This is, I didn't draw one at all. And then last is, I incorrectly drew both of them. And so it goes on like this throughout your whole rubric. I'll let you read through it, but it's really important to read not just the 4 column, but the 3 column. How will I miss a point? You know, if I forget one thing between here and here, what happens? Okay, so good luck, and I will see you tomorrow.